June 28, 1944. Normandy. The air smells of oil and burnt cordite. Rain drizzles over the bocage, turning the narrow French lanes into rivers of mud. A column of U.S. Shermans grinds forward, engines roaring under the gray sky. Their armor, still slick from salt spray off the landing ships, bears streaks of soot and shrapnel scars. Then it happens. A flash from the tree line. A German 80mm round punches through the first Sherman's side plate. The tank jerks. Flames burst from the turret ring, and black smoke rolls upward. The crew barely escapes before the ammunition cooks off. Far behind the front, in a makeshift repair yard lined with canvas tents, a mechanic named Sergeant Joe R. wipes grime from his hands and watches another burned-out tank arrive. Its armor is twisted, its interior charred. But what grabs his eye isn't the wreck. It's why it burned. He kneels beside the ruptured hull, traces the path of the fire to the ammunition racks, and mutters a thought that would soon spread across Europe. If this keeps happening, we won't have any tanks left. That night, using scrap metal, hoses, and borrowed tools, he begins testing a field fix that will change how the Sherman fights, and survives. When America entered the war in December 1941, the M4 Sherman was more than just a tank. It was a promise. Reliable, fast, and simple to produce, it became the backbone of Allied armored forces. Factories in Detroit, Cleveland, and Chicago rolled them out by the thousands, an industrial rhythm that Germany could never match. But as the war expanded, so did the enemy's firepower. By 1943, the Sherman, armed with a 75mm gun, was already struggling to pierce the frontal armor of the new German Panther and Tiger tanks. The Sherman's greatest advantage wasn't its gun or its armor. It was its numbers and its ability to keep moving. Crews could depend on it to start every morning, to cross terrain where heavier machines bogged down, and to be repaired with spare parts scavenged from wrecks. Yet reliability came with a fatal flaw. When a Sherman was hit, it often burned. German crews called it the Tommy Cooker. Americans had their own grim nickname, the Ronson, after a cigarette lighter. Lights every time. The reason was simple. The Sherman's ammunition was stored in racks along the hull sides, unprotected by anything but thin armor. A penetrating hit could ignite the powder charges, turning the interior into a furnace within seconds. Many tankers died not from explosions, but from the fires that followed. Reports from North Africa, Sicily, and Italy told the same story. Tanks hit once, sometimes even glancingly, erupted in flame. Ordnance officers issued orders to improve stowage, but production could not change overnight. Out in the field, survival depended on improvisation, and mechanics like Sergeant Joe R. knew it. By the time of the Normandy invasion in June 1944, tank losses were staggering. In some units, more than half of all Shermans knocked out were lost to internal fires. Replacement tanks arrived daily, but so did more burned-out hulks. Frontline mechanics and engineers began experimenting with crude field modifications, moving ammo boxes lower in the hull, welding extra armor plates, even rigging makeshift fire suppression systems using CO2 canisters from aircraft. It was dirty, improvised work, but it was also American ingenuity at its rawest, the kind that didn't wait for approval or blueprints. These experiments were often undocumented, yet word spread quickly between tank battalions. Soldiers talked in mess lines and motor pools about units whose tanks didn't seem to burn as easily. Mechanics took notes, swapped sketches, and refined each other's work. And behind it all, men like Joe R. pushed forward, learning from wrecks, testing what worked, and sharing results through letters or convoy chatter. As the war ground deeper into France, this bottom-up engineering culture would quietly evolve into something far more systematic and far more effective. By late summer 1944, the Allies had learned a hard truth. Production alone couldn't win the tank war. Innovation had to happen on the ground, fast, local, and often unauthorized, at forward maintenance depots scattered behind the lines. The U.S. Army Ordnance Corps turned into something closer to a laboratory than a workshop. Mechanics who'd once worked at Ford or Caterpillar were now operating under tarpaulins, surrounded by wrecked Shermans, scavenged German armor plates, and a supply of coffee that never ran out. They weren't waiting for engineers in Washington. They were experimenting, welding, and testing under fire. One of the most important fixes came from observing a grim pattern. Tanks that burned had ammunition stored high along the hull. Those that didn't often had rounds left untouched in the floor bins. A few mechanics began relocating shells deeper in the hull, surrounding them with makeshift containers filled with water, antifreeze, or glycol, whatever was available. These crude wet racks worked. Fires were slower to spread, giving crews precious seconds to escape, sometimes even to fight on. Word reached the Ordnance Department quickly. Engineers back in the States took note of these field improvisations and began designing a standardized wet stowage system. The new layout sealed each ammo rack in a jacket of liquid designed to absorb heat and smother sparks. Tests showed a staggering result. The risk of catastrophic fire dropped by more than 70%. But long before this system became official, men like Sergeant Joe R. had already proven the idea worked. Using damaged tank parts, aircraft CO2 lines, and even canisters from firefighting equipment salvaged from airfields, they built makeshift suppression systems that could be triggered manually. These field mods saved countless lives in Normandy and the battles that followed. At the same time, the British were experimenting with their own version of the Sherman, the Sherman Firefly, fitted with the powerful 17-pounder gun. American mechanics took note of those conversions, blending ideas across Allied lines. It was a rare case of wartime creativity spreading laterally, not top-down. While the British focused on firepower, Americans in the field were focused on survivability. By August 1944, some armored divisions had fully adopted these unofficial modifications. Their crews were more confident, morale stronger. They knew that if they were hit, they might still make it out alive. Behind every repaired tank was a crew of grease-covered men who turned wrecks into weapons again. Their efforts went largely unrecorded, but the results were undeniable. Fewer burnouts, fewer funerals, and tanks that stayed in the fight longer. As autumn approached, those same modified Shermans began facing the German counterattacks in Lorraine and the Ardennes. The real test was coming, one that would reveal whether field innovation could truly stand up to Germany's best armored divisions. The story of that test began on a cold September morning, when the fog of eastern France lifted to reveal the silhouettes of panthers moving toward the town of Aricourt. War is often remembered through battles and commanders. But on the ground, survival came down to people who solved problems faster than they died from them. Among tankers, that meant trusting the quiet men in the repair yards, the mechanics, welders, and ordnance technicians who kept the steel moving. Most of these men had no formal military training before the war. They'd been mechanics in Ohio garages, machinists in Pennsylvania mills, or farmhands who fixed tractors with wire and luck. In the field, they worked 16-hour days, covered in oil and sweat, sleeping beside their tools. They patched bullet holes with scrap armor, forged parts from wreckage, and made sure tanks rolled back out before nightfall. Their job didn't bring medals or headlines, but every tanker knew their worth. Crews would often bring coffee, cigarettes, even spare rations to the workshops, a silent acknowledgement of debt. "Keep us rolling," was all they asked. Mechanics like Sergeant Joe R. didn't invent new machines. They refined survival. Each field modification, a welded plate, a rerouted fuel line, a water-jacketed ammo box, carried the fingerprints of necessity. When one tank returned from combat intact, Others copied its changes immediately. No orders were needed. The front was its own chain of command. There was a human rhythm to it. Fight. Repair, adapt, repeat. By mid-1944, the field fix culture had become an unofficial doctrine of American armor. Crews and mechanics began to anticipate problems before they occurred. Gun mounts were adjusted to absorb recoil better, transmissions fine-tuned for rough terrain, and improvised side skirts attached to resist Panzerfaust blasts. The Sherman's reputation was slowly changing, not because the design itself evolved overnight, but because the men using it refused to accept its limits. They didn't see themselves as innovators. To them, it was simple. If something kept killing tankers, it needed fixing. And the fix had to come today, not next month. This practical, unglamorous mindset, born in workshops and field depots, would ultimately give the Sherman a second life on the battlefield. And when those reworked tanks met German armor at Eracourt, the difference would be measured not in theory, but in survival. If the human side of the Sherman's transformation was grit and improvisation, the technological side was precision under pressure. Every small improvement came from trial, error, and observation, and every successful idea quickly turned into a standard. The most significant breakthrough was the wet stowage system. Instead of keeping ammunition dry and exposed, the shells were enclosed in compartments filled with a water glycol mixture. It was a simple concept with life-saving consequences. When a shell rack was hit, the liquid absorbed the heat and prevented the powder from igniting. Crews reported that fires, once almost guaranteed, now rarely spread beyond the first seconds. At the same time, mechanics experimented with externalizing danger. Fuel tanks were repositioned farther from the engine compartment. Fire extinguishers were upgraded from single-use bottles to manual systems routed through flexible tubing. It was all crude, functional engineering, no aesthetics, no elegance, just survival. Then came the armor fixes. Mechanics welded extra plating scavenged from knocked-out German vehicles, particularly over the sides and front glacis. These improvised applique armors gave the Sherman a distinctive, scarred appearance. Patchwork proof of field innovation. The extra weight strained suspensions, but crews accepted the trade-off. Better to change a road wheel than bury another friend. Meanwhile, the Army's technical branches caught up. Reports from field depots were compiled, photographed, and sent back to U.S. factories. By the time new Shermans rolled off the lines in late 1944, they included features that had started as unofficial fixes in France. It was one of the fastest design feedback loops in military history. The Germans, for their part, noticed. After-action reports described American tanks that were resistant to secondary combustion, meaning they didn't burst into flame after a hit. Panther crews found that where one shot used to disable a Sherman permanently, it now often took 2 or 3. To American commanders, this change was invisible on paper, but unmistakable in morale. Crews began to trust their tanks again. Mechanics were proud. Their battlefield science had saved lives. This fusion of human courage and mechanical innovation set the stage for what came next. The Battle of Eracourt. It was there, in the rain-soaked fields of Lorraine, that modified Shermans, patched, reinforced, and carrying wet stowage racks, faced off against one of Germany's last armored offensives. And for the first time in the war, the outcome would prove that the Sherman's so-called weakness had become its greatest strength. Adaptability. September 19, 1944. The Lorraine countryside lay under heavy fog. Dew clung to the hedgerows, muffling the sound of engines until they were almost upon you. Near the French village of Eracourt, elements of the U.S. 4th Armored Division were spread thin across the rolling farmland. Their Sherman tanks dug in among orchards and barns. To the east, the German 5th Panzer Army advanced, hoping to break through the thin American lines and retake ground lost after the fall of Nancy. Their spearhead, dozens of Panther tanks, represented some of the best armor Germany had left. At dawn, the fog began to lift. What followed was one of the most remarkable tank battles of the European War. A contest not of numbers, but of adaptation. The first Panthers appeared on the ridgelines, dark shapes emerging from the mist. U.S. tankers, alerted by radio and aircraft observers, opened fire from concealed positions. The Shermans were outgunned, but this time they were different. These weren't the thin-skinned, fire-prone tanks of North Africa. Many were field-modified, carrying wet stowage systems and crude armor welds. When German shells struck, sparks flew and steel dented. But the familiar bursts of flame didn't follow. Crews stayed inside, reloaded and fired back. Lieutenant Colonel Creighton Abrams, commanding elements of the 37th Tank Battalion, later described the engagement as a knife fight in a fog. Sherman crews maneuvered rapidly, using their superior turret rotation and speed to flank the slower Panthers. Mechanics' earlier modifications, extra armor plates, better gun stabilizers, and improved ammunition racks were now proving their worth under fire. German commanders, expecting an easy victory, were caught off guard. Reports later described their disbelief that so many Shermans survived direct hits. Panthers that paused to aim found themselves outflanked, others bogged down in the soft fields. By noon, the battlefield was littered with burning Panthers. American tank losses were real, but far lighter than expected, and far fewer burned out. The men in the workshops had done their job. The field fix had become a battlefield advantage. And as the fog thickened again that afternoon, the Shermans advanced through the smoke, proving that survival wasn't luck. It was engineering, forged in desperation, and perfected under fire. By the second day at Aricourt, the battle had shifted entirely. The Germans continued to push westward, sending in more Panthers and Panzer IVs to regain momentum. But the Americans, drawing on radio coordination and relentless mobility, turned defense into ambush. Fog once again blanketed the valley. Visibility dropped to 50 yards, perfect for the Shermans. Their crews, working in coordination with artillery spotters and P-47 Thunderbolts circling above the clouds, began striking from unexpected angles. Panthers, designed for long-range duels, now found themselves trapped in close-quarter brawls, where their thick frontal armor offered little advantage. When shells slammed into modified Shermans, the difference was unmistakable. Inside the turrets, men stayed calm, sometimes stunned by a hit, but no longer blinded by fire. The wet stowage racks hissed and steamed, extinguishing sparks before they could ignite. Mechanics' handiwork had turned terror into seconds of grace. Seconds that saved lives. Seconds that won battles. In one clash near Rechicourt-le-Petit, 4 Shermans held their ground against a column of Panthers until reinforcements arrived. 2 were hit, neither burned. Their crews later re-entered the tanks after field repairs and fought again the next day. It was a quiet revolution unfolding in mud and smoke. The German reports from Aricourt reveal growing confusion. Tank commanders noted that American armor showed abnormal resistance to internal fire, and that their enemy maneuvered faster than expected. To them, it seemed as though the Allies had introduced a new tank overnight, but it wasn't new. It was the same Sherman, reborn through the ingenuity of its users. By September 29th, the battle was over. The Germans had lost more than 250 tanks and assault guns. The U.S. 4th Armored Division lost around 25 tanks in comparison. Aricourt became proof that the Sherman's strength was never in its armor or gun. It was in its adaptability. Each battlefield lesson, each improvised fix, had built toward this moment. When the last fires died down, mechanics returned to the fields, hauling damaged tanks back to the depots. Their work wasn't done. The next battle was coming, and for every Sherman they repaired, they added another quiet improvement. Another reason why the next crew might live to see home. When the smoke cleared over Lorraine, the battlefield looked like a scrapyard of metal giants. Dozens of Panthers lay gutted across the fields, their thick armor blackened, their turrets blown open. Scattered among them were the Shermans, scarred but intact, many of them already marked for recovery and repair. The victory at Aricourt stunned both Allied and German analysts. For the first time, the U.S. Army had defeated a major armored offensive without numerical superiority. The reasons were many: superior coordination, faster logistics, flexible tactics. But hidden beneath those headlines was another truth. The mechanics had changed the odds. After-action reports from the 4th Armored Division confirmed it. Tanks equipped with improvised or standardized wet stowage showed a dramatic drop in crew fatalities. Fires that once consumed entire crews now rarely spread beyond the turret ring. The data told the story that the frontline soldiers already knew. The field fix worked. Ordnance teams in Europe immediately compiled these findings and relayed them to the Armored Board in the United States. Within months, new production Shermans were being shipped with integrated wet stowage systems, redesigned fuel lines, and improved ammunition racks. For the tankers who fought in France, these upgrades weren't just mechanical changes. They were a symbol of connection, proof that the lessons learned in muddy fields were shaping the war machine back home. Mechanics, who once worked in anonymity, began receiving formal commendations. Their unofficial ingenuity had become official doctrine. The press never covered their names. The public rarely heard their stories. But for every tank crew that survived because their Sherman didn't burn, those nameless men in grease-stained uniforms were the reason. The story didn't end there. The influence of their work would continue far beyond the hedgerows of France. As the Allied armies pushed deeper into Germany, through the winter of 1944 and into 1945, the lessons of Aricourt followed them. The Shermans that rolled across the Rhine were no longer the same machines that had landed at Normandy. They were hardened, improved, and far more survivable, shaped by the hands of soldiers who had refused to accept defeat as a design flaw. The official wet stowage system was now standard. Tanks with these modifications reported an almost 80% reduction in burn-related losses compared to earlier models. Fire suppression systems, once improvised from air hoses and CO2 bottles, were redesigned and installed as permanent features. Ammunition was moved to safer positions, and engineers reworked armor layouts to reflect battlefield realities rather than theoretical testing. Even after victory in Europe, these lessons echoed forward. The post-war M26 Pershing, born from late-war experience, incorporated many of the concepts proven by those frontline fixes: better ammo protection, improved crew safety, and easier field maintenance. During the Korean War, tankers still credited the wartime ordnance ingenuity that began in those canvas repair tents of France. Historians would later describe the Sherman as the tank that won the war, not because it was perfect, but because it could evolve. It was a machine that changed as fast as the men fighting inside it. For the Germans, the defeat at Aricourt marked a turning point in morale. The myth of invincible armor was shattered. Their most feared tanks, the Panthers and Tigers, had been beaten not by new Allied weapons, but by smarter ones. And for the Americans, that victory wasn't celebrated with parades. It was marked by a quiet satisfaction in the workshops, a sense that ingenuity, not luck, had saved lives and helped win a war. That spirit of adaptation would define U.S. armor for decades to come. In every war, technology tells only half the story. The rest is written by the people who refuse to give up when the machines fail them. The Sherman tank began the war as a compromise. Fast, reliable, but dangerously flammable. It ended the war as a symbol of endurance, not because of a single invention, but because of thousands of small, human decisions A mechanic's late-night experiment, a crew's field adjustment, a commander's willingness to trust his men's ingenuity. What happened in those muddy workshops across France was more than repair work. It was a quiet revolution in thinking. The idea that innovation could come from anyone, anywhere, if it meant saving lives. The same spirit that built assembly lines in Detroit was now keeping tanks alive in Europe. For the men who fought inside those steel hulls, survival wasn't guaranteed. But when the next shell hit and the interior didn't erupt in fire, they knew someone, somewhere, had thought ahead for them. That unseen bond between crew and mechanic, between the fighters and the fixers, helped carry Allied armor to victory. After the war, most of those mechanics returned home, went back to their shops, and never spoke much about what they'd done. Yet their legacy rolled on in every tank that came after. Safer, smarter, more adaptable. In the end, the story of the Sherman wasn't about steel, gasoline, or fire. It was about resilience. The quiet kind that doesn't ask for recognition, but changes the outcome all the same. A tank designed in haste, improved in desperation, and perfected by the hands of its users became one of the most enduring symbols of American ingenuity. And it all began with a mechanic who looked at a burning wreck and decided that wasn't going to happen again.